Good afternoon, friends. So I welcome you in today's lectures. This lecture will be delivered on hazard risk and vulnerability analysis by our Sri S.K. Ghosh, Senior Consultant NDA, MA, and former Senior Scientist of AERB BRC. He will deliver this lecture in two parts, today and tomorrow, on the same topic. And this is a pre-recorded lecture. So without taking any further time, I will switch over to the recording now. Thank you.
Good afternoon. Myself S.K. Ghosh, Senior Consultant from NDMA. Now, topic itself, you could see that hazard, risk, and vulnerability and assessment. Let us start the job. My way of thinking, see, I have done earlier. I have done earlier one lecture, if you remember. That was a way forward for CBRN, and that time I asked you to few questions and work out whenever you get time. So again, I am repeating that. I think you might have got the answers. So the first question was, before 2005, all disasters were looked after by Ministry of Agriculture. Why? Why that was so? 2005, the Disaster Management Act was passed. Subsequently, it was handed over to PM. Now, this answer you might have got. If you have not got it, I am telling you the answer. Answer is that earlier the people used to think disasters meant either it is a flood or drought. So that means people will be starving and they need food. So best ministry is the agriculture to take care. So that was the only concept. They do not think of beyond that. So that was the answer. Now second, I asked the TDS. TDS means time, distance, shielding. TDS is applicable for all kind of severe and disasters. Severe means chemical, biological, radiological, nuclear. I asked whether it is applicable for all kind of time, distance, shielding. That day also I answered the same thing. Yes, it is applicable and it is effective also. Chemical also and biological also you have seen during COVID. So that answer is yes. And third is the purpose of bioweapon. I ask what is the purpose of bioweapon? To kill the people or to destroy the economy or what? See, basically it is not the killing the people. The COVID, if you have seen, people might have died because of lack of some logistic infrastructures. But that was intention was not to kill the people; it is to destroy the economy and social infrastructures. That was the main purpose. And you will get further details. Our experts will be there in the bio disaster management. He will give you further details. And then those who are from background from DAE, they may be knowing the answer. Difference between nuclear and radiological material. Till today, I have been giving lectures in airport and seaport. People are not knowing the nuclear radiological difference. Why these two terms CVRN is there. So you may be knowing already. So nuclear only from where the nuclear energy is generated. There are basically three elements, uranium, plutonium and thorium we consider nuclear material. Remaining all are radiological material. But if accident happen, let it from any origin, nuclear or radiological, ultimately we will call it radiological emergency. That you be clear in your mind. Then I ask another question, X-ray machine, is it radioactive? I used to get 99% people used to say yes, it is radioactive, but it is not so. Until unless you put on the power supply, it will not generate any of the electromagnetic wave which is causing harm to people. It is not a radioactive, okay? It is a radiation generating equipment. Be clear. And then last questions I ask, what are the three L's for PSFA? Psychological support for first aid. So that is look, listen, and link, that you might have got in the my PPT itself. And then the last questions I have given you the homework. CBRN, why C is first, why not B, why not R, why not N? So that answer I could get it from internet, because I used to get this question from all places and different answers are coming. Just have a look on that. CBRN is the ICRC, International Committee of Red Cross, standard abbreviation. Various acronyms may be used elsewhere. You got the point? They have been generated from International Committee of Red Cross. Some older name, English, they call NBC, nuclear, biological, chemical. Then French, they give the name of NRBC. And then German, they have given ABC. Then Spanish, they give QBR in bracket N. And nowadays it is frequently used CBRNE. That is explosive also has been added. So now, however, you can find out the better explanation if possible. I could get this is the explanation from searching different literatures. Now come back to today's topic. So today's topic is with respect to chemical hazard risk and vulnerability assessment. How you will be doing it? The objective of undertaking that HRVA is primarily to anticipate the potential problem and possible solution. Anticipate. You have to understand the problem first, then you can find out the solution. To help and save lives, protect property, assets, and to reduce the damage and facilitate a speedy recovery. HRVA short form is a means towards becoming disaster resilient and is not an end in itself. That is the understanding. So now what will be the goal? Goal is a critical part of disaster risk reduction program to prepare for emergency, to make a risk-based choice, to address vulnerability, mitigate hazard, and prepare for response and recovery from hazard events. So these are the goals of the HRVA. Now why? When and why hazard identification is required? When planning, designing, and modifying the installation and process. Let it be anything, it be chemical or something. Suppose there's an insurance company wanted to have this. This is applicable for all kind of planning. To ensure that critical examination techniques such as risk analysis, hazard, and operability studies are used. In doing so, see, there are several methods, fault-free, event-free. Those who are a little bit aware of that, see, the PRA and PSA is nowadays have become a tool to prove that certain events are very rare events, or certain events are can happen. So that fault-free and event-free analysis are used many places, and it should take into account the external event as well, internal and external both, in the process of hazard identification. So such studies will indicate where the hazards may be reduced through engineering design or not. That's why hazard identification is important. Now, usefulness of quantified risk assessment. See, if you are able to quantify the risk, it is well and good. But if you are not able to quantify, then we call it sometimes deterministic approach or probabilistic approach. You have to follow the path. So it will be guiding you for decision making safety issues. So QRA allows the relative ranking of risk, which risk is more dangerous, which risk you can just manage with some engineering measure like that, and provides an aids for preventive measures. However, QRA should not be used indiscriminately. You should not always try to justify quantitatively, no, this event cannot happen. It can provide guidance to the public authorities in land use, planning, be an aid for industry in decision making, and could facilitate the transparency in decision making process and allow for a relative ranking of risk. Now, here I have put a red colored questions for you to find out. Do you know what is DID, defense in depth philosophy? If you have heard, please go through some literature and find out that what is defense in depth philosophy, where it is used, and why it will be very helpful for tackling the emergency situation. Right now, I am not giving the answer. In the second part, I will give the answer, but it is the food for thought for all of you. Now, need for safety reports. You know, in nuclear industry, I belong to nuclear industry. As a regulator, I work. So we always ask for safety analysis report. Let it be PSR or FSR, but that is required. They have to anticipate all safety risk assessment and submit it and prove that the plant they are going to design is totally safe. So conduct risk assessment based on the hazard identification and prepare safety report describing the significant hazards. So conduct assessment based on the walkthrough process of risk identification. Now, understanding hazard. See, now I think you have already have some classes before me for definition of hazards, vulnerability, risk, all these things. Still, there is no harm for repeating. A potentially damaging physical event, phenomena, or human activity which may cause the loss of injury, property damage, social, economic description, environmental degradation. Hazards are placed everywhere. It can be latent, sometimes just like earthquake, it's a latent hazard. It can happen in even volcanoes. There are latent hazards. You do not know what is happening inside the earth. It can come out. So we have to anticipate and take data of 10 years or so and so. Similarly, environmental degradations and other things, all hazards you have to take into account. And hazard can be single, sequential. Just like sequential, you understand the tsunami happened in Japan. People might have died for tsunami, but as a consequence of that, nuclear power plant, they lost their power supply, and that 4 reactors, there is the severe core damage happened, and that's why Fukushima has become famous. But the initial cause was tsunami. So that's why I'm talking about sequential or combined with their origin and effect. Each hazard is characterized by its location, intensity, and probability. So understanding the vulnerability. So hazard may be present everywhere, but if vulnerability things are removed, then you can tackle the things. Suppose earthquake happen in the Sahara desert, but there is no people stay there, so there is the vulnerability is very low. So a set of condition and process resulting from physical, social, economical, environmental factors which increase the susceptibility of a community to the impact of the hazard. You remember now, during the COVID, we used to say those who are comorbid, they should be very careful. Comorbid, already they are vulnerable to that COVID. Other people, those who are healthy, they could survive because of their capabilities. So that is we'll call it capacities afterwards. So vulnerability is not equal for everybody. So positive factor that increase the ability of people and society they live in to cope with effectively with hazard, that increase their resilience, and that otherwise reduce their susceptibility is considered capacity. So that is the capacity factor. So understanding risk, again I told you the probability of harmful consequences. So I have explained risk is present everywhere. So how to remove the risk and how to reduce the risk, that is a beautiful formula. Risk is equal to this, you might have already come across, hazard into vulnerability divided by capacity. As capacity increases, risk will decrease. Hazard increases, risk will increase. Vulnerability increases, increase. So beyond expressing the probability of physical harm, it is crucial to appreciate that the risks are always created or exist within the social system. You cannot remove the risk is there, but we have to manage the risk. How you are managing, that is important. It is important to consider the social context in which risk occur. That the people therefore do not necessarily share the same perception of risk and their underlying causes. I given the example of COVID, that comorbidity was because of that different vulnerability aspects. Now, this is a very good diagram I have copied from the this gentleman name is there, and 1999, Grant 2002. This is a, we call it triangle. If you increase any of that either vulnerability, hazard or exposure, any sides, this is risk is going to increase. Now, I do not know, you can calculate it, see, triangle area, you know, S into S minus A, S minus B, S minus C square root. That way, any sides if we increase, S will increase and corresponding area will increase. So, this is a beautiful diagram. So, that reference given by gentleman Crayon in 2002. So, you can have a look on that. Is a good way of representing the risk. Now, what chemical agents are hazardous? So now I am talking about, today's lecture is about the chemical hazard risk vulnerability analysis. So I have to know what are the hazardous chemicals. That includes substance brought into the workplace and handled, stored, used for processing the raw material, solvent, cleaning agent, glues, resin, paints, so many things. So, substance generated by the process of activity, vapors, dust, they are all hazardous material, and substances are mixed produced at workplace, including byproduct and residue or waste where you are working. Now, these are the symbols. I think Dr. Kunal Sharma might have told you. These are the symbols easily available. You can identify what type of hazards with each of the symbols. In case of flame, you can see that there are two diagrams. Flame over the circle and flame within the circles. So these are all available in the literature, and this is OSA, I have copied it. You can have a look on that. This corrosive atmosphere, skull and crossbones, all this is specifically the identification of hazards with the symbols. Now, which form it is? See, chemical agents, all chemicals are not hazardous to you because what they contain. Sometimes, see, I will tell you, give an example. Here, that atmosphere may be very toxic, but if your ventilation is proper, control measures are taken place, then see, threshold values you are able to maintain. Obviously, this cannot cause harm to the people, those who are working on it. So workplace, see, water, is hazardous? No. But if you prepare a hot water and steam, it is hazardous to you. So the way you are using that material, that's give you whether it is hazardous or non-hazardous. So water, maybe cold water, you may like it to drink during summer, but steam you get burned, so you try to avoid it. So like that, why control the risk of hazardous chemicals? Why we should control? Because thousands of people, see, you cannot avoid chemicals. See, there are lakhs of chemicals, and every day you are consuming chemicals some of the other forms, let it be medicines, let it be your biscuits, let it be any of the cold drinks, whatever you use, basically they are nothing but prepared with some of the chemicals, maybe suitable for your body, but sometimes it will cause serious illness, sometimes even death if you take excessive. The effect of hazardous chemicals may be immediate or long term. Cigarette smoking is injurious to health, it's known to everybody. So, but still, people smoke it for their habits also, but it gives long term impact and sometimes it become a chronic health hazard. So, how to reduce the chemical risk? So the risk is equal to hazard into exposure into vulnerability. Just look at it. So we can improve our ability to monitor and forecast the hazards. In NDMA, we have got a common alerting protocol. Now, those who are having mobile, they may be getting SMS. Those who are present, suppose in Delhi area or Uttarakhand, if before earthquake, we are able to give some kind of alert message. People will be, those who are cyclone prone area, we are giving alert message. So that is we can improve our ability to monitor and forecast the hazard. Then exposure, increase awareness. See, if we can explain the community and the hazard, so they may take care and reduce the exposure. Similarly, the greatest benefit you can achieve by reducing the vulnerability of natural hazard. So you have to reduce the vulnerability. Now some more relations, hazard into vulnerability into exposure is equal to risk minus capacity. These are all definitions, and those who want to study further, I will give a link. There is a good compendium, so you can have a look on that. So that's next slides. See, there are the process. HRVA is a 9-step process. That's process. I've explained it. Now this is the book from where I have taken the material. This is nice book in 2020. I think it has been just put it, go down. Not quite. So if you see, it's not moving. It says move down. So this is emergency. British Columbia has presented it in 2020. It's a very good companion guide, and those who want to further details the study of hazardous vulnerability is 9-step. It's very nicely explained, and for each and every process, not only chemical, let it be any physical process or preparing a building or preparing a dam, anything. So these are very good tools they have been given, and I think it is a 96 pages document. Just now I'm rolling through. Just you can have a look on that. So this is that. I will not take much time, but this will be available with you. So this is a 9-step process. See, I have given getting started. See, all of you may be knowing www dot, but I have written www.h. So this full form is why, when, where, how. See, if you ask these questions yourselves, you will get answers. Then only you are starting the hazard risk vulnerability analysis process. So identify the hazard first of all, where you are staying, where the chemical factory is being built. Then understand community risk and resilience, when, and assess the hazard. Sorry. Choose the appropriate methods. Methods have been described in the literature. I told you either it can be faulty or event tree analysis. Assess the consequence. Build a risk profile. Identify the risk reduction strategies, and generate a report. Report generation is very important. Until unless you generate a report, people will not be able to understand what you have studied and what is the outcome accordingly. And of course, review and approval is required by the authority, those who are going to use it. Now this is a very good HBR cycle I have given you. This is before pre-incident, incident and post-incident, what are the things you can use it. And this is also in same documents, it is available. So preparedness, this whatever study will be doing it, this will help in preparedness. And mitigations and prevention, of course, it is a part of the entire process. And then response and recovery is coming the incident, after incident and post incident phenomena. And of course feedback from one incident going to again improve upon these cycles. Now effect of hazardous material. Now some examples of the hazardous chemical includes, I think Dr. Kunal Sharma already explained, skin burn, irritations, being overcome and losing consciousness, following the inhalation and toxic fumes, suffering acute symptoms such as headache, nausea within hours of inhalations, poisoning, absorption, skin absorption. There are several skin rashes, genetic damage of offspring occurring years after exposure. If you remember that our Bhopal, that still those who are born, they are having some kind of defects, genetic defects we call it. Now, what do you need to do? See, now you are getting trained and you are becoming experts for hazard risk vulnerability analysis. So assess the risk from hazardous chemical agents at your workplace. You will be employed or you are working somewhere. You can do yourself the exercise. Decide what control measures are needed. These control measures must be identified, specified in writing. You tell your organizations or your bosses that these are the risks. I need to reduce the risk by so and so engineering measure. Ensure that control measures are fully implemented and operational. Then only your job is over, not before that. So, how do you assess the risk? A number of key questions to be asked. What substance are workers exposed to? I am sitting in this room, nothing is there. But if you are sitting in a place which is very near to chemical factory or your chemical factory premises, there will be several substances, raw materials. They generate fumes and they generate toxic gases. So persons who may be affected, plant operators, maintenance personnel, cleaner, contractor, visitors, everybody, those who are entering the premises. When the chances of exposures are more, when there is a leakage. See, if you have seen, if you travel through some nearby chemical factory, you will be seeing the night or in the early morning, you will get more smell. You may not be knowing what for. I do not know industry. Maybe sometimes discharging their gases in the night times, so that you might have observed it. So chances of exposures are more at night if you travel near the factory. Now, where to get the informations? Informations you do not know when you are, suppose you want to build a chemical factory, where to get the information? Information may be obtained from safety data sheets, other information provided by the suppliers, from the trade organizations, from plant equipment supplier, and from specialists working in the industry. So material safety data sheets is very important source of information, and you can have it in your premises or in factory. Useful you can also information from internet. Nowadays it is a encyclopedia, nobody look at it. Internet is very good source of information, provided you are looking for the particular data. Sometimes it may not be available, but with a lot of R&D you can generate it. Some generic data and some specific data also may be available in the literature, and fire or explosion risk will be always there with all chemical industries. Now coming back, what questions you are asking? What activities can give rise to exposure? Whether it is leakage, failure of some equipment, or mixing of some fluids, Sometimes we call it explosion happen. If you put some water in sulfuric acid in front of you, there will be explosion. If you throw a piece of sodium in water, immediately fire will happen. So what activities can give rise to exposure? You have to understand that, the process. Under what circumstance my substance be breathed or swallowed in or absorbed through the skin, that you have to understand. And what risk need to be controlled. Suppose somebody is handling sodium, you cannot openly handle it. You need to have a controlled environment without any air, without any oxygen. What are the chances of contamination? Contamination word is very famous. Now, during COVID time, people used to say, don't carry contamination, it's a contaminated object. But nuclear industry, it is not today, it's last say 70 years, we use it, contamination words. But you have to know chemical contamination, how to remove it, biological contamination, how to remove it, like that. You have to ask questions. And how they react with other material. These are all key questions. Once you turn your head and do some work, you will find out the answer. Our exposure are likely to be significant. And this depends on the duration, frequency of exposure as well as the concentration. See, if somebody is passing through nearby the chemical industry, does not mean he will immediately fall sick. But those who are working 8 hours and they inhale, so that exposure time is more. So you have to know that it's significant how much the concentration will be allowed and what malfunction or accident could result in serious exposure. And the threat of fire and explosion need to be guarded against everything. Now look for, what you look for. If good practices for dealing this with the risk is well established, you only need to identify the relevant measures in writing and check they are in place. Appropriate safety culture at workplace. Incident information exchange systems and feedback mechanisms should be there. So I use a word safety cultures. I just this is a very vaguely sometimes use it. People don't confuse it with our normal culture. We can say, okay, this is the culture of this community, not that culture. Safety culture. Can you define somebody? This is the homework for all of you. How to define safety cultures. I will explain it in next slides. But you try to find out what are the definition. You know, there is a guide available internationally on safety culture itself. After Chernobyl happened, no, the safety culture word was coined, and in nuclear industry it has a very good document available. But you work on that. I will explain it in next lecture. Now, how do you specify the control measures? So once you have done HRVA, hygienic vulnerability, the measures and precautions you can identify. You need to find out what is the established good customs and practice in your industry for managing this risk and check that you meet these standards. Advice in good work practices and standard used from other employers in the same business. Sometimes they do not share the informations, but if you get the informations, your risk factor, you can reduce it considerably. From plant equipment supplier, of course industry specialist, and from published authoritative guidance. Now special attention is needed when special attention is needed. If your work process is unique, just keep it in mind. See, those are nuclear industry. Now, international community, India was not given the technical know-how in several cases. So this process is unique to us, unique to the nuclear industry. They need to understand. And authoritative guidance and good health and safety practices not available. So that's why special attention have been given. So that the regulations is very stringent for nuclear industries. But I will come afterwards. The regulation in chemical industry is not so effective. You will need to formulate a regime of control measures that will reliably prevent any adverse health effects. The regime may draw on the following hierarchy of the measure in order of preparation. First and foremost is eliminate, if possible. Change the process of activity. If you find this is the vulnerable area, this is the hazard area, so you eliminate it. How? How to eliminate? You have to find out engineering judgment, and it may not be always possible. Okay, so that elimination may not be always possible. Now look next, what is the step you can follow? Substitute. So if you are not able to eliminate, replace it with safer alternative. See, earlier if you see several chemical raw materials, they used to have some other raw materials. Nowadays they have changed it to safer raw materials. You might have seen that CFC is not used. We are using a green material which can reduce the carbon rating. So separate the hazardous substance from the workers. That is also substitution. And then engineering control. This is in your hand. Use physical measures to minimize workplace contamination. That is extraction at source by local exhaust ventilations. This even though looks very simple, but in many places you will find that ventilations people don't get importance. And we call it air changes. See, very good practices there, that fresh air should be there in your workplaces, and continue work changes. It may recur sometimes 2, 4, 7, 8, depending upon the contamination level or depending on the threshold value of that toxic substances. Then administrative control. Use safe work practices. Procedures should be there to minimize contamination. Good hygiene procedures should be there. And the last and final, it should be personal protective equipment. When you have exhausted all other measures, then provide face mask, gloves, protective clothing, etc. But not the last resort. You should use this last resort till you are not able to control by the other measures. So now if you just simple diagram it, till hierarchy has been given. So first is eliminate. So eliminate what? Eliminate, physically remove the hazard. Very good. So that should be the priority. Then substitute. If alternate material which is eco-friendly is available, so replace the hazards. In chemical industry is very much needed. You can do some R&Ds and substitute the raw material itself. Then of course engineering control. Engineering control has to be there. I already talked to you that DID, defense in depth measures are always in help in engineering control measures. So isolate people from the hazards. Those who are working, to those multiple layers of isolation should be available. Of course, administrative control should be there. How much air changes and how many hours you can work on that. So there should be several rules available in your factory or those who are operating the factory. And then finally, protect the workers. When suppose there is a, I know there is a factory, they store H2S. Now, any people going to any area, they need to have the PP kits with them. Even then, they cannot sustain for more than 2 hours, because the breathing apparatus they will be carrying that can give maximum 2 hours supply of oxygen. So this PP kits is must for those who are hazardous industry, but there are no other alternative. So you have to follow this hierarchy. And I think this, if somebody has understood clearly, and he can do lot for hazard risk and vulnerability analysis program. So the control measures themselves must also be checked and maintained at regular intervals. See, you have given the control measures, but it is not maintained. That valve, see, you know, the emergency, you may be seeing that fire hydrants are available for every societies, in your society also. But when it is required, recently I had a mock exercise in Delhi airport, and I went to that where they give control of landing and take up for our flights, and there was a fire hydrant. I asked them to open, there was no water coming. I was surprised, such an important installation, then fire hydrant, and water is not coming out. So this happened because this emergency doesn't happen always, and when it happens, emergency gauges may not be workable. So it has to be maintained at a regular interval. Local exhaust ventilations equipment should be examined, operated at a regular interval, we call it surveillance. And sometimes it is necessary to monitor the worker exposure at regular interval by measuring concentration in air and ensure that exposure limits are not exceeded. Health surveillance. So this is annual medical checkup is must. Those who are working in hazardous industry, particularly chemical industry, toxic industry, and it has been followed in the atomic energy. All nuclear power plant, I know, they go for annual medical checkup, and if required, they will get additional follow-up action. Now with this part 1 I have completed. If you have some questions, and whatever questions I have asked you, you just generate your answer, and I will see you in next tomorrow. Thank you very much.